Hello, so we're on to lecture 16 on series, and we're going to be talking about alternating series and the alternating series test in this lecture. First off, what is an alternating series? It's going to be a series whose terms go back and forth between being positive and negative. So in general, an alternating series can be thought of as a series of the form -1 to the n times an, where an is positive, because that's going to go back and forth from positive to negative. But the idea is you're going to go back and forth. You could start with a positive or a negative. It doesn't matter. I guess this one starts with a negative. I'll make that +1. Make it a positive. So your terms look like plus or minus something, right? So you're going to be saying a1 minus a2 plus a3 minus a4 plus a5, or it's starting with a negative and bouncing back and forth that way. Okay, so what's happening with alternating series? Let's just think of this in terms of a number line. So let's suppose we start with a positive number. So I'm going to add a1 to 0. So that's just that first term. The first partial sum is a1, right? That's s1. Now, what's happening after that? Well, a2 is going to be negative, but we've already seen that in order for this series to converge, to have any hope of converging, the terms have to be going to 0, right? So that means that eventually the terms are going to be decreasing. The length, the size of them is going to be decreasing. So we're heading back in a negative direction. So negative a2 is going to head us back this way, and it's not going to head us back as far as where I started because the terms are decreasing. And actually, the terms are eventually decreasing. At some point, this is going to happen, decreasing to 0. So now what's happening here, when I go to the next term, that's going to be positive. So I'm going to go forward in that. Again, that's going to be going forward less than what I went back this way because we're decreasing. That's adding a3 onto it. And when I subtract a4, I'm going back this way, right? Less than where I started. So what's happening here? I'm spiraling in around. And I'm going to spiral in on something. In other words, we have the following big theorem, nice theorem. If you happen to know your series is an alternating series converges if and only if the terms in it go to 0. If the terms don't go to 0, then it diverges by the divergence test. If the terms do go to 0, that's enough if you've got an alternating series to say that the series is going to go to 0. So alternating series are actually a little bit easier to deal with than regular series. Let's look at an example, just a quick example. I equals 1 to infinity of -1 to the I over I. So that's going to be -1 plus a half minus a third plus a fourth, so on down the road, minus a fifth, right, etc. This is what we call the alternating harmonic series. And, well, the terms go to 0, therefore it converges. Terms go to 0, so it converges. That's all you have to check. In fact, we can get an idea of what it converges to, because look at this. The first partial sum was here, right? This is S1. Second one is here, S2. Third one's here, S3. The limit's going to be between consecutive partial sums once you're at a point where the terms are decreasing, that the ANs are decreasing completely. Here the ANs start decreasing, right? 1, 1/2, 1/3, 1/4, 1/5. So if I take a couple partial sums out, I can get an estimate of what it converges to. Like, for instance, if I go from, let's not go too far out, from 1 to 3 of -1 to the I, and from 1 to 4. my sum, what it converges to, is going to be between these two things. So this is going to be -1 plus 1/2 minus 1/3. So a half and minus a third is 1/6. That's going to be minus 5/6, right? And this is going to be minus 5/6. So I've got a -1 plus 1/2 minus a third plus a fourth, which is minus 5/6 plus 1/4, which is minus 10 plus 3, right? 12, so that's minus 7/12. So the series converges to something between minus 7/12 and minus 5/6. Okay, that's a good place to stop.